opener? Hey. Hello? Hello? Sorry. I think those were the Polish words that I know. Hey. Hello. That also means the same thing, pronounced the same way, and spelled the same way in Swedish. I think that's fantastic. Anyway, today I'm going to talk a little bit how to fail a software project fast and efficient. And my background is I'm a developer. I've been doing that for quite a while. When people ask me what I'm doing, I usually say I write computer programs, because that's what I do in one way or another. So the goal today is to describe some patterns that will help you fail, if you're interested in failing. How many here are interested in failing? Okay, one. Okay. So I hope you already know all of this material. I've divided it in some different ways to do it. You can either make sure that the organization that you're working within has a lot of problems. You can make sure that your management are bad. Make sure that you have a bad architecture. Apply bad development practices. And of course, make sure that the user interface is unusable. And now I'm a little bit surprised. I'm missing an image. Yeah, okay, so I used to have an image where a guy is shooting himself in the foot. That one has been broken. Sorry for that. So, strict division. If you're working in an organization, make sure that you divide everything very, very strict. Make sure that there are some people who do the analysis of the problem, some other people who doesn't speak to the first guys, doing the architecture. Development should be done by another department. Configuration management, of course, yet another department. And testing within another department. And especially if you're co-located, say that you're sitting in one floor in one office, so everyone can talk to each other, but make sure that they don't. That's very important. How many in here are working in an environment or organization where you're dividing the line organization, that is, you have a manager who is manager over all developers, and then you have some kind of project that is more or less cross-functional. One, almost, a couple guys, right, lucky you. So make sure that you have a line manager who is your manager, but only manager for, say, developers or testing. And make sure that you divide all the employees between different projects. So you have a project manager who doesn't have anything to say about when you're having a vacation or something, or for that matter, raise, if you have on the salary or anything like that. Yeah, so divide employees between the projects. So make sure that you have two parallel organizations that doesn't really speak with each other. That's a great thing. Communication. Always prefer written communication. Why? You can read it at any time. And you don't have the opportunity to ask questions about the text. Everything that is in text is what we're saying and nothing else. It has to be interpreted. And losing information in translations, that's very common. I spoke to some guys yesterday. They had 3 translations from the wish list where someone wanted something until they were allowed to develop it. Interesting. And a great way to lose a lot of information. So if you want to fail, written text. Customers. Make sure we don't speak to them. Make sure that they never meet the developers. Because if they do, they will probably just mess up the heads of the developers. They have a lot of new ideas and stuff. Have probably deviating from the specification or something like that. So make sure we don't meet the customer. That's also great. Development and operation. How many in here are developing something and then throw it over the wall to an operation department? Not too many. Okay, so the rest of you are operating it yourself, I suppose. Well, that's one way to do it, but make sure that you don't allow developers into production systems. They will probably just break something. So, but make sure also, at the same time, that they have to develop deployment packages, deployment scripts. So they have to develop the stuff that you will actually use to put things in production. And if you're not allowed to into the production systems, then you won't even be sure where scripts are located. Do you have any absolute path that you have to refer to or not? It makes things a lot more interesting if you don't allow them to see the production systems. But at the same time, devs should also, of course, be responsible for bug fixing. But they're not allowed into production systems. They can't look at logs and stuff like that easily. Improvement. Make sure that you avoid improvements one company at a time. Make sure that you hire personnel with the right skills from the beginning. Don't send them courses. I mean, if they're educated, why should you? They're educated, they already know this stuff. Conferences. You're at the conference, so I guess your manager hasn't understood. Don't send people to conferences if you want to fail. They might learn something. Books. Books should of course be read on personal time, always, and don't pay for them. Don't buy your developers or any of your employees any books. That's just a waste of money. And if they might even read it on company time, which of course is very expensive. So you should learn new things on personal time. How many in here are actually learning new things on personal time? Okay, so you're obviously not the group that these managers. You are the group that these managers actually want to work with because you're interested in your work. Measuring. How many in here are being measured? Yeah, some of you. Ever heard the expression, you will deliver as you're measured? People will deliver as they are measured. If someone tells you 85% test coverage, you will deliver 85% test coverage. Will the test be good? I don't know. We won't talk about good tests, we'll just talk about test coverage. Another way to do it is how many bugs has one person fixed, for example, without it making any difference. So difficult bugs, critical bugs, or simple bugs. A bug is a bug is a bug. So fixing, I don't know, something that might have to be pixel perfect on a GUI, that's one bug. Making sure that it's possible to log in into the system, that's another bug. These may be on different scales, but don't take that into account. One bug is one bug. So that's one way you can do things. And moving over to management. How can management assist in the goal of failing the project? Well, we could talk about resources. Refer to people as resources, because that implies that they could be exchanged. A resource such as, I don't know, a pile of gravel that you would put on your house or something, that could be replaced with some other pile of gravel, or for that matter, moving things using a truck could be done using another truck. That's a resource. If we're talking about development, then it's actually not that easy to replace one person with another person, because the first person may have a lot of knowledge about the system. But if you refer to people as resources, then they are, by definition, replaceable. And can, of course, be replaced. Meetings, lots of meetings. Schedule them. Because meeting is a great way to communicate. And demand that everyone is attending, even if they might not have anything to say. But they should be there because there could be something important said. So lots of meetings. But cancel them late. As late as possible. Perhaps even after they have started. Or don't show up. So if you're a manager, if you're the boss, then you may be allowed to do this. I'm the boss, I don't care about you. So don't show up. Or at least cancel them very late. Or if you do show up, make sure that you're unprepared. That this will send a signal to the guys at your meeting that they are not important. A great way to make sure that they're not motivated. Daily stand-up. Are you doing that? Yes, some people say yes. They're just uncomfortable. And I think they're quite annoying. So don't do them. Go for a weekly dev meeting instead. A couple of hours, say Friday afternoon when everyone is very tired. But once again, cancel them. They're more worrying. So cancel them often, if you can. Written communication. I'm coming back to written communication. So always demand minutes of meeting afterwards. Someone should write the protocol. That's very important. Planning. Well, we all know that planning is everything. As generalized, our plans are everything. No, planning is everything. So make sure that you plan way ahead. And make sure that you have all the details within the plan. So you know that the plan has a value. Follow it very, very, very strict. Otherwise, why should we even plan? So of course we should follow it. Ever heard of collective planning? Don't do this. Because then you have a lot of different opinions about how stuff should be done and whatever problems you may find. Problem solving should be done alone. So one person should estimate all tasks within the plan. 12 months ahead. And make sure that this person is a really good guy, clever guy, who's really fast, so we actually make sure that you don't get too much time for completing the tasks. Planning poker, well, I've heard about teams doing that. I don't know. I guess they're hippies. And it's probably just a waste of time. Detailed control. Make sure that you always have control of all details. This is very important as manager. Don't allow people to self-organize. They will probably just fail. Demotivation. Has anyone ever been demotivated by a manager? Not everyone, some will. So one way to make sure that people are demotivated is, of course, criticize them. And do it in public, so everyone hears. Tooling. No. Why should we invest in tools? There are great free tools out there. So don't invest in tools. Large screens, anyone? Why? I mean, we should write small methods, shouldn't we? Why should we have a large screen for that? I don't get it. And as a manager, I want to have the best computer. Because I'm doing really hardcore stuff. I mean, I might even use a browser. So, yeah, I should have the largest screens, the largest screen, and the fastest computer. I mean, I'm a manager. Working off-site, like working from home, make it extremely difficult. Make sure that the employees don't have their laptops to move around. Make sure that you don't set up a VPN. No external SSH. It should be impossible to work from home. because then people will show up at the office, and then you're able to have control. That's good. Overtime, anyone? You like it? Well, you get paid for it. That's nice. So 40 hours a week, I mean, that's just for whims. We're developers. We can do like 60, 80, no problem. And if you can't, then you're probably a bad developer, and we don't like bad developers. But if you demand overtime, make sure that you don't have any clear goal. Why are we doing this? Just demand it. People will love doing lots of overtime. I mean, who want to spend time with their family? Boring. Coding standards should of course be defined by committee, because committees, they make the best decisions. And of course a management committee, because they do the development. Or maybe not. But I mean, they're managers for a reason, so make sure that they have opinions and define any coding standards that you have to use. 100% test coverage, that's a great goal. I think we should demand that. Because anything else is a failure, then we don't test drive our code, for example. So anything but 100% is a failure, so demand that. And I mean, it's not that hard to achieve 100% test coverage. Simplest possible solution would of course be don't assert anything. So 100% for sure. TDD, nope. Testing should be at last. Like in this great metaphor of the waterfall, we plan, we implement, and we test, we deliver. So add testing last. But at the same time, of course, demand 100% test coverage. Javadoc, we want to make sure that the systems are well documented. So there should be 100% Javadocs. And quality, as I said, add that at the end. And why? It's very simple. Because when we're at the end, then we have the system ready, then we have something to test. We don't test anything that isn't done yet. So if we test very early, the system is not even written, and it for sure doesn't work. So why should we even test it? I don't get the point. So make sure that you add testing last. And especially performance. If we build the system and it turns out that it's not fast enough, well, fix that at the end. Don't build performance in from the beginning. Deployment. Deployment is, of course, very risky. We have no problems with deployments. We do it as seldom as possible. There are people talking about every day or every week or every month. But, I mean, there's a lot of risk involved. Things could go wrong. So make sure you don't do it too often. Every 6 months, every year, shouldn't that be enough? We shouldn't take too many risks too often. And while we're at it, make sure that deployment is done in different environments by different people. You may allow the configuration manager to do it in your test systems, but in the production system, they are much too important to leave it for the configuration manager. That should probably be done by some kind of hosting partner or whatever that does this, like, I don't know, once a year. But they're professionals, so they should be able to cope with it. So make sure that you deploy different environments and make sure that it's done by different people. And reduce the number of times, of course. And maximum, I would say, perhaps every 6 months, twice a year. Not more often than that. And always avoid small releases. Because small releases, they don't deliver any value for the customer. Make sure that you release large things that actually deliver value for the customers. Continuous deployment. Oh, of course not. Has to be done manually, so we know what we do. You can't leave deployment of our important system to machine. They will probably not do it correctly. Improvement. Retrospectives. Don't think so. Because then there will be just a lot of people whining. This doesn't work, that doesn't work, this is bad, boring. We don't want to hear that. So make sure that management define all improvements instead. When they are, after all, managers. They should know this. And they will probably do it very, very good. So avoid regular retrospectives. It will just be, I don't know, not very nice having a lot of complaints thrown at you. Broken builds. Well, it's a fact of life. Sometimes the build breaks. It doesn't compile. What should we do? Well, we should not stop the line and fix it, that's for sure. Because, I mean, we're not like any kids playing football. We don't run for the ball. All of us have one person fix it. The rest of the guys, they should of course continue with their important daily work. So don't stop the line, don't fix the build, or at least don't make sure that the entire team is involved in fixing it. That was management. Architects, architectural things. Yeah, it's possible to break a project just by using, well, a good architecture. Policies. One of them could be, of course, to enforce some common framework. 1, 2 should solve all problems. So make sure that you have one common framework that everyone is very familiar with, and that should solve the entire problem. So if you have different problems, make sure that you use the same framework. 1, 2, yep. So make sure that everyone is equipped with one good tool, say a hammer. Then all problems will look like nails, and that's a good thing. Same development environment, of course. You should be standardizing this. Otherwise, you will only have a lot of people setting up their own system as they want. And why should you allow that? Well, make sure that you have company policies and enforce everyone, and make sure that you enforce it properly. Ivory tower. Architects should sit on an ivory tower, because then they have the possibility to look at the landscape around them. And have them write stuff and throw it at the head of development, to the head of the developers. And if they're not sitting in their ivory tower, they might not be able to see all the surroundings and understand all the connections. So this is very important. Simple design is of course the simple problems or simple systems. Anyone working with a simple system? No, I didn't think so. Complex systems demand a complex design. So the more complicated things are, the more complicated design you need to solve the problem. So simple design, that's for simple systems, and we don't do that. But design is very important, so make sure that you have a committee who is doing it. They should take all important design decisions. But make sure that they don't have any regular meetings. Make sure that you can't foresee when you will get this decision taken. I mean, we are all out, after all, out to fail this project, aren't we? System communication must, of course, be system agnostic. You should be able to plug in any other system to communicate with your system. XML over HTTP, anyone? Yeah, that's a great thing. It will probably triple the amount of bytes that we send over the network, which of course is a good thing. And we have to package the XML, we have to repackage it. So XML over HTTP is actually perfect. Singletons. Well, they have the good property that they support global variables, and of course also global state. It may look like this. And I think we have about 5,000 classes here, and I think a quarter of them is connected, something. That's perfect. We could connect even more if we put some effort into it. Yeah. So singletons are a good thing. Development. Good practices. We should avoid good practices. This is an image of an Hungarian doctor who I have got his name. Silverweiss. He introduced the good practice at a hospital in the mid-1800s. Oh, sorry, 1900, 1856 or 1850 or something. They had quite a high death rate among women giving birth. Like 35% of all women giving birth at this hospital died. So he enforced that you should wash your hands after you have done some autopsy and then go to deliver a baby. Doctors didn't do that before. So he reduced the death rate from 35% something to something around 3 or 4%. You could do that, that would be a good practice possibly, but avoid good practices when you do development. Specifications. Of course, they should always be written, so you can go back and reread them. Now getting back to this written communication. Great way to make sure people don't really understand what you mean. Have you ever tried to ask your text, what did you mean? I haven't. But I would expect to get null as response, or nothing, if you want. So always written specifications. Could look like this. This is a specification I have written. And I'm especially proud of this part. When are we done? I don't know. I don't care. So definition of done. Well, everyone knows when it's done. We don't have to have a definition of done. Why should we? Everyone already knows. Common language, same thing here. We don't need that. Everyone knows what we're talking about. There's no risk in misunderstanding each other, especially not between development and business. I mean, we do speak the same language, most of us. And if not, we can always use some common denominator, say English. My Polish is unfortunately a little bit bad, so that would be a problem for me if we were speaking Polish, but, well, no. I'll probably go anyway. So no need for common language between business and the development. We don't need any system metaphors either. We all know it should be in the system. We all have the same view of it because we're working with it and we have read the specification. Version control system, well, no, I don't think so. A shared disk should be enough. And if you really need it, I mean stuff like Subversion, Git, Mercurial, No, that's just hippie systems. Anyway, clear case, that's the way to do it. That's the place to do. Continuous integration. That's just a waste of resources. I mean, everyone here knows how to write a computer program. When we know that it works when we write it. Some of us has even compiled it before we checked it. So it should work. So continuous integration, that would be a waste of time and resources. Developers, if a file is missing, have them chasing it down. They have to walk around the office. Did you forget that file? Did you forget this file? And eventually they might find who actually forgot the file. It may take a half a day or something, a day. And why not? We're out to fail. That's our goal. Code ownership. I've heard about teams where you have collective code ownership, but no. One person, one developer should be responsible for one module, or each module. So this person owns the code here. And you're not allowed to touch it. If you need to change there, you have to ask that developer to do it. So he knows what has been done, because he owns this code. It's his baby. No one else is allowed to touch it. Pair programming. I had a session about pair programming yesterday. I was probably wrong. It's probably inefficient. It's very expensive. I mean, 2 guys, 1 computer. Hey, come on. Refactoring, no. Do it right from the beginning. I mean, we're professionals. We should be able to do it right from the beginning. That's why we had plans. And that's why we had all the details in the plans. To get it right the first time, redoing, that's just unprofessional. Non-functional requirements, well, load testing, must cope with high load. That's clear enough. We know what high load is. Load testing, yeah, when we're done, if we really have to do it. But isn't that a sign of that we just failed? If you have to do it, use the right tools. The right tools is probably something that you built your own. Tools like JMeter or, I don't know. That's just the wrong tools, I guess. Functional testing should of course be manual. Otherwise we can't for sure say that it works or not. Should always be done through the user interface, of course, because it's a user interface that people are using. So that's where we should do the testing, of course. Yeah. User interface. Make sure you test the easy parts first, because they're easy. That's easy to test. Avoid the difficult parts as long as possible, because they're probably they're so difficult and they're probably wrong anyway. So why should we go there? Focus on stable areas. Why? We have to write a lot of bug reports otherwise. That's annoying. Takes time. Boring. Test evenly. All parts of the system is equally, or all parts of the system are equally important. Otherwise, we could have played some of them. So everything is equally important. So test evenly. I mean, creating an administration account is just as important as perhaps putting stuff in a shopping cart or selling stuff. So make sure that you test everything equally and evenly. Yeah. And I mean, no one should get any extra attention. Everything should be equal. That's good. So no extra attention. for anything, for any specific area. Corner cases, well, they are always the most interesting cases. So let's focus on them. Most common cases, they will be tested anyway. And that's just boring, just mainstream corner cases. That's the place to test. Colors. Does everyone see every color? I guess you do, I don't. Man, don't be afraid to use colors. Red and green. Red text on a green background. Perfect. Then I won't be able to see it at least. That's a good thing, I suppose. Automation. Testing should be done manually, as I said earlier. Tools like Selenium, Fest, or whatever, they're just difficult to use. They just break. And it's way too important to leave testing to a computer. So avoid automation at all costs. I mean, the computer can't say if an interface is nice or not. I think it should look like this, actually. We have some unit tests in the bottom. Top of it, we have some integration testing, some automated unit tests, maybe. But most of our testing is done at the top. This is a way to do automation. But everything I said here is of course wrong. If you put no in front of it, it might be right. So if you negate everything, you might end up with something that I think could work. That would not guide us to the goal of failing the project. Anyone heard of Agile Manifesto? 1, 2, okay. Those of you who haven't heard of it, look it up. Read it, do some thinking about what do they say. It's not about how you do stuff, it's about values. So for example, it's a lot better to value individuals and interactions instead of processes and tools. Working software is of course a lot better than having a book written about it. Working together with the customer, yeah, that's obviously better than negotiating contracts. Responding to change, yeah, a lot better than following this detailed plan that we have laid out 12 months ahead with all the details. It has a lot of different principles. I suggest that you read them and think about them. There's always also the XP principles. Anyone heard about extreme programming? Okay, a few of you. Look it up as well. This is where we started out with test-driven development, pair programming, continuous integration, refactoring, small releases, and so on and so on. Sustainable pace is one of my favorites, which is about programmer welfare. Make sure that the guys working on the system don't get too tired. Demand 40 hours a week, but not more. Forbid overtime. Why? We want to be able to run a marathon. If we go out to run a marathon and we do it in the same tempo as we would run a 100 meters race, we would probably die after 150 meters. And if I understand correctly, it's not that hard to run, or it's probably very hard, to run 100 meters under 10 seconds. So let's do it in 20. Let's do it in 30 seconds. But make sure that we can do it for a long period of time. So anyone interested in these manifestos, or Agile Manifesto, the XP principles, take a look at here, at these resources. I have a blog where I sometimes write about, I mostly write tutorials, but sometimes other things as well. The last thing I wrote was, I'm claiming that every system is equal. They are equal. You add stuff, you store stuff, you get it back. At the lower level, there's a lot of differences. At the high level, they are very similar. So, I'm still Thomas. I still write computer programs. Thank you for listening.